All right, this is Chapter 5, Lesson 6, Add Linear Expressions. So, if I'm adding linear expressions, we need to first understand what a linear expression actually is. So a blank blank is an algebraic expression in which the variable is raised to the first power and variables are not multiplied or divided. So in those blanks, you're going to write linear expression. Okay, so a linear expression, so linear, it forms a line. When I have exponents higher than 1, it actually forms curves and things like that. So linear expression forms a line. The table below gives some examples of expressions that are linear and some examples of expressions that are not linear or non-linear expressions. So non-linear, not linear. They don't form a line. Okay. So linear expressions include 5x, 3x plus 2, x minus 7. Okay. Non-linear expressions, so 5 and n, they're two variables that are multiplied together. 3x cubed, variable raised to an exponent higher than 1. X to the fourth, variable raised to the exponent higher than 1. Okay. You can add linear expressions with or without models. I'll show you both ways. If you want to use models, that's fine. Sometimes you will need to use zero pairs. Okay. So we've talked a little bit about zero pairs, but we haven't used that exact terminology. So basically what zero pairs are, they're additive inverses of one another. So basically when you add them together, they give you 0. So that's what zero pairs are. All right, so if I want to add 2x minus 3 plus negative x plus 4 using algebra tiles. Again, you don't have to use algebraic tiles in order to do this. You can. It makes your life easier, especially if you enjoy manipulating things with your hands, like moving things around. You can absolutely use algebra tiles. Okay, you can draw them, you can manipulate them, you can move them. So, algebra tiles, 2x minus 3. So basically, when you're using algebra tiles, you need 4 colors. Okay, you need 1 color to represent your variables. That's positive. 1 color to represent variables that are negative. 1 color to represent constants that are positive, and 1 color to represent constants that are negative. So 4 colors. Okay? So I'm adding 2x minus 3 plus negative x plus 4. So the first thing I'm doing when I'm using algebra tiles is actually creating what the expressions are. So for example, 2x minus 3. I have 2 green x's because they're positive, and 3 red squares because they're negative constants. Okay, so my greens are positive variables, my reds are negative constants. Okay, then negative x plus 4, I have an orange x because it's a negative x, and then 4 positive yellow tiles. Okay, so now I want to go ahead and think about, okay, which ones can I use to cancel each other out so I can create some zero pairs. So if I look down here, I rearrange them. I put all the x's together and all the constants together. Okay. So when I do that, I have 2 green and 1 orange. Well, the green and orange cancel each other out because I have a positive x and a negative x. They form a zero pair. Okay. Same thing with my constant tiles. I have 3 red tiles and 3 yellow tiles that cancel each other out. They're zero pairs of each other, and I have 1 yellow tile left. So this gives me my solution to my adding linear expressions. So I have 1 positive x plus 1. I can do the same thing with find 5 times the value x minus 4 plus 2x minus 7. Okay? But I have one more step here. I have to use the distributive property in order to solve this. So 5 times the quantity x minus 4. 5 times x gives me 5x. 5 times 4 gives me 20. Okay? So I have 5x minus 20. Now, if you don't want to write or manipulate all of these tiles, you don't have to. Okay? So what I can do is I can look and see where my like terms are. I'm adding them together. So I have 5x minus 20 plus 2x minus 7. So 5x plus 2x, I have 7 x's total. Negative 20 plus a negative 7. Negative 20 plus negative 7 gives me a negative 27. Okay? So when I add them together, I get 7x minus 27. If you want to draw the algebra tiles out or use the algebra tiles, use them. That's fine. Okay, you'll still get 7x minus 27, regardless of how you do it. Okay, but you may have to be drawing for a little bit because it'll take you a while to draw 20 tiles, or an additional 7 plus the 5 plus the 2. Okay, but make sure you're using the distributive property first. All right, there are a couple of try it problems on the page. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try problems, let's go over the answers together. So the first question I have is find x minus 1 plus 2x plus 3. Use models if needed. So for this one, I'm actually going to go ahead and use the model so you can actually see what it looks like. So I have 4 colors. Okay. My oranges are going to be positive x's. So I have x. Red's going to be negatives. Minus 1. Okay, and then I have 2x plus 3. I'm going to use purple for 3. Positive. Okay. So I can actually see that I have 1, 2, 3 orange x's. So 3 positive x's, so 3x. And then I have a negative 1 and a positive 1. They cancel each other out. And I'm left with 2 positives. So 3x plus 2. All right, then I have find 6 times the quantity x plus 7 plus x plus 3. Use models if needed. So I'm going to go ahead and use the distributive property first, and then I'm just going to add. I'm not actually going to use models for this one. Okay? So I have 6 times x and 6 times 7, which gives me 6x plus 42, and then x plus 3. So I can actually line them up just like you would a normal equation. Okay, so like if I were just adding equations, adding numbers together, normal numbers. Okay, 42 plus 3 gives me 45, and then 6x plus 1x, because this is really 1x, gives me 7x. So 7x plus 45. All right, now I have find 12x plus 19 plus 2 times the quantity x minus 10. So again, I can use the distributive property. You can use models if you want to. That's fine. I'm going to use the distributive property first. I have 12x plus 19 plus 2x minus 20. Because 2 times x gives me 2x. 2 times 10 gives me 20. And the minus sign stays the same. So again, I can add these like I normally would. 12x plus 19 plus 2x minus 20. Okay? 19 plus a negative 20 gives me a negative 1. 12x plus 2x gives me 14x. So 14x minus 1. Okay. Again, you can use models if you want to. It'll take you a while to draw them out, but you can do that. I'll go ahead and do that for you as well, just so you can see what it looks like. You still get 14x minus 1. Okay, so you'll still get that answer. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. These are x's, and then I have positive 19. Okay, so here's my 12x plus 19, and then I have 2x, and then minus 20, I can see that I have 12 plus 2, I get the 14x, and then I can also see that I have 4 here, so they cancel, 4, cancel, 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 and I have 1 left over, so 14x minus 1. And that is the end of Chapter 5, Lesson 6.